All right, hi everyone. Today we are doing section 7.4 and we're going to start talking about what factoring means. So today we're going to factor some polynomials. We really haven't done any factoring yet, so you might have no clue what this even means. But we have done some other operations with polynomials. So really quick, just to show you kind of where we were at before we got here. And you don't have to write this down, I got a couple examples over here. So this week so far, we have learned how to add and subtract polynomials. So we did stuff like this first example here the other day. This is when you just combine like terms. So we would add, we can't add anything with the 2x squared, but we could combine the 5x with the 4x, and then we would combine the -2 with the 10. And then we would just go ahead and simplify all of that, right? We also learned how to do that with subtraction. So if this plus sign was a minus sign, we learned how to deal with that. And the other thing that we did was multiplying polynomials. So if we have two polynomials, these are actually binomials. If they're right next to each other, that means we multiply, and we learned that we can basically just use the distributive property. So we multiplied those two, and then we multiplied these two, and we ended up with something like this, x squared plus, this would be minus 7x, and then plus 5x, minus 35, and then we combined those middle terms, right? So this is what we did the other day. So far, that's all we've done with polynomials. Okay, so now we're going to talk about what it means to factor a polynomial. So in order to understand factoring, I kind of want to show you something else that we've done before. So let's take, for example, 2 and then in parentheses, x plus 5. If I gave you something like this and I asked you to multiply this, we all know how to do that, right? We would go 2 times x, 2 times 5. We would just use the distributive property, and then that would be 2x plus 10. Now, this is called multiplying, right? Factoring is kind of the opposite of multiplying. It means figure out what was multiplied in order to end up with this. Now, we know what factoring means with regular numbers. So, for example, if I asked you to take the number 10 and factor it, you would say, okay, 10 is the same thing as 5 times 2, or 10 is the same thing as 1 times 10. That means these numbers, these are factors of 10 because they both multiply to get to 10, right? Now, when we have polynomials, the factors look a lot different. The factors of 2x plus 10 are this right here. It would be 2, that's one of the factors, and the other factor is x plus 5. Because if you take these two things and you multiply them together, you end up with 2x plus 10. So factoring is kind of like undistributing, which is not really a word, but it kind of makes sense for today. So for example, in this box, I want you to put 3x plus 12. So this is a polynomial. It's specifically a binomial. It's got two pieces. And we're going to factor this thing. So in order to factor this, you basically undistribute. So we're going to put parentheses here, and we're going to figure out what was on the outside of the parentheses and what was on the inside of the parentheses. Go ahead and think about that for a second. I'm going to not speak for a minute. I'm going to let this video just kind of play. I want you to think about what would be on the outside and what would be on the inside. If you want, go ahead and try to write it down. Okay, so here's the answer. We would have a 3 on the outside, and then in order to get the inside, you have to think about, okay, 3 times what equals 3x? Well, that would be x. And then 3 times what equals 12? Well, that would be 4, because 3 goes into 12 4 times, right? And this would be the answer. This is called the factored form. So we took a polynomial and we just factored it. The best way to double check your work here would be to just distribute and see if you get what you started with. 3 times x is 3x, 3 times 4 is 12. So this would be perfect. Now, when you factor using this method, this is called taking out a greatest common factor. And the greatest common factor in this example would be 3, because 3 goes into both of those terms. So we'll talk more about how to figure out what that is in a second, but this is generally what we're doing today. We're just factoring out the greatest common factor between these two terms. Now, sometimes there will be polynomials that can't be factored. You'll see one of those today. If they can't be factored, we're going to call that prime. That's what it's called when it can't be factored. Okay, so here's the steps for doing this. Again, this is called factoring out a greatest common factor, or we can use GCF for short. So the first thing you need to do is identify what the GCF is. So there's a couple things you're going to look for. You're going to look at the numbers, the coefficients, which means the big numbers, and then you're going to look at the variables. So let's just go ahead and do our first example right now so you can see how to do this. Now, I'm about to insert some clips from an older video, just because I've already recorded this a couple years ago. The examples that I'm going to show you are identical to the examples in your notes. It's just going to have a pink background instead of a white background. So it's going to look a little bit different, but you will see that all the examples are exactly the same. So I'm going to go ahead and insert a clip of me doing all of these examples right now. And you can still follow along on the note sheet that you have in front of you. The first thing you want to do is look at the coefficients, which is just the numbers. So let's just start with the numbers, 5 and 15. And you want to find the GCF of those coefficients. So what is the GCF of 5 and 15? Well, the factors of 5 are 5 and 1. That's it. And then the factors of 15 would be 3 times 5 or 1 times 15. So the number that they have in common would be 5. 5 goes into both of those numbers. So we know that we're going to put a 5 on the outside. The next thing you want to do is find the GCF of the variables. Sometimes there won't be one, but sometimes there will be. So if you look at the variables, they both have x, right? And you can only take out the most that you can. This one only has 1, which means we can only take out 1. I can't take 2 because this one doesn't even have 2 to give up. So I can only take the smallest amount that you see. So we're going to take one of the x's out. So I'm going to put 5x on the outside. And then on the inside of your parentheses, you just have to divide both of these terms by that GCF. So that's step 3. Divide each term by the GCF. And then we're going to write whatever we have left on the inside. So let's go ahead and do that. So if I divide 5x squared by 5x, well, the 5's are going to cancel. One of the x's is going to cancel, and I would just have one x left over. If I divide 15x by 5x, well, the x's will cancel, and 15 divided by 5 is 3. So this would become a positive 3. And then this would be our answer right here. And again, you could always check this by distributing. So you could just distribute and make sure that you would end up with this. And we definitely would. 5x times x is 5x squared. 5x times 3 is 15x. All right, so let's go ahead and do the rest of these. I'm just going to do them exactly the same way I did the first one. I'm going to start by looking at the numbers or the coefficients. What is the greatest common factor of 2 and 8? So you got to think about what number goes into both of these numbers. And that would actually be 2. 2 goes into both of those numbers. So that is what we're going to write on the outside. And then you have to look at your variables. They both have x, and what's the smallest amount of x's you see? I see that there's 2 here, so that's the most that I can take. I can't take any more than 2 because, again, this one only has 2 to give up. So that's the most that I can take. I'm going to take 2 of the x's, so x squared. And then I'm going to divide both of these by 2x squared, because that's my GCF. So 2x cubed, if I divide 2x cubed by 2x squared, well, the 2's will cancel. And x cubed divided by x squared, I would only have 1 x left over, right? So 2 of these x's would cancel out with 2 of these, and I would only have 1 left. So remember quotient rule, right? If you divide these, you end up with just 1 x left over. So this would be x in our parentheses. If I divide 8x squared by 2x squared, well, the x squareds cancel out, and 8 divided by 2 is 4. So this becomes plus 4. So that is the second one. All right, so this one, let's start with the numbers. So what goes into 15 and 10? So I know that that would be 5. 5 goes into both of those. Now this one has an x, but this one does not. So we cannot take an x out. We can only take the 5. So if I take 5 out, well, if I divide this by 5, that would become 3x. If I divide this by 5, that would become 2, and we have that negative right there, so I'm going to bring that down, minus 2. So that would be our answer for that one. Okay, this one's a little tricky. So if you look at this and you look at the numbers, there's nothing that goes into both of those besides 1. And you never really want to take out a 1 because that's not considered factoring if you just take out a 1. So there's nothing that goes into both of these. The letters are also different. So since the letters are different, that means that these actually have nothing in common. There's nothing that we can take out, which means this is not factorable. Anytime you cannot factor it, we call that prime. So this would be a prime polynomial here. We cannot factor this. So we're just going to write prime. Okay, so that should be the end of the front page. Go ahead and flip the page over and we'll do the examples on the back. Okay, we're actually going to go ahead and skip that first one just because we did it on the front. This was the one where we did 3 on the outside and then x plus 4 on the inside. So we'll skip that and we'll just move straight into the next one. All right, what's the greatest common factor here? Well, it looks like it could only be 7, right? 7 goes into both of those. And then on the inside, if you take the 7 out of this, you would just have the y left over. If you take the 7 out of this, remember 7 divided by 7 is 1. So we would have a 1 left over, or a negative 1 since there was a negative. All right, in the next one, 8 and 36. What goes into both of those numbers? Well, let's see. It would be nice if 8 would work, right? Does 8 go into 36? Nope, 8 does not go into 36, so we can't use 8. So you have to start thinking about what else goes into 8. Well, I know to get to 8, you could do 1 times 8 or 2 times 4, right? Let's see if 4 would work because we're trying to find the biggest number, right? So let's see if 4 would work. Does 4 go into 36? Yes, it does. It goes into 36 9 times. So 4 would be our greatest common factor. And then if you look at the letters, well, those are different letters, so I can't take out one of the letters. So let's go ahead and divide by 4. If you divide this by 4, you would get 2m. If you would divide this by 4, you would get 9n, and that would be our answer. All right, so this one, there's no numbers, so we're just going to look at the letters. They both have an A in common, and that's it, right? So that would be our greatest common factor. And then if you take that out, well, for the first part, I would just have the B left over. And for the second part, it would be A divided by A, which is 1. So I would have minus 1 right here. All right, let's see what goes into 6 and 27. Well, I know the factors of 6 are 1 times 6 and 2 times 3. And I know the factors of 27, 1 times 27 and 3 times 9. And that's it, right? So let's see. What do they have in common? It looks like 3 is the only thing that they have in common besides 1. So we're going to take out 3. And I can't take out any other letters because this one does not have any letters. Okay, so now let's divide each term by 3. If I divide this by 3, we would have 2a squared left over, and 27 divided by 3 is 9, so plus 9. All right, and the last example, so let's see, 5 and 13. Well, those don't have anything in common. There's nothing that goes into 5 and 13 aside from 1. So nothing there. Same thing with the letters. The letters are not in common either. So we would call this one prime because it cannot be factored. All right, and then we have some examples here that just take a little bit more work. So some with multiple letters. So let's go ahead and do these. So in the first one, I see a coefficient of 3, but I don't see one on the other term. It's technically a 1, right? Now there's no common factors here besides 1. So we don't have to worry about the numbers. Let's just focus on the letters. So if I look at the letters, let's see, they both have x's, right? Now this one only has one x, so that's the most that I can take. They also both have y's, and they both each have 1, so we can take 1. So that would be on the outside, and then what's left on the inside? Well, if I'm taking out xy, so on the first one I'm taking out xy or dividing by xy, the y's would cancel, and I would have 1x left over. So I'm going to put x right here. If I take out xy over here, well, the x and the y would both cancel, and I would be left with 3, so plus 3. And this would be our answer. In the next example, we do have coefficients, so let's start with those. So what goes into 15 and 30? So we got to, and remember, we have to take the biggest number possible, because 15 and 30, they actually have quite a few common factors, right? So for example, 15, if you think about the factors of 15, well, we would have 1 times 15, 3 times 5, and that would be it. If you think about factors of 30, factors of 30 would be 1 times 30, 2 times 15, 3 times 10, 5 times 6. So if you look, they have 3 in common, they have 5 in common, and they have 15 in common. But you have to take the greatest common factor. That's what that G stands for in GCF. You have to take the largest one, and the largest one would be 15. So that is what we're going to take out. So 15 would go on the outside. And then if we look at the letters, so let's see, they both have A, right? And we can only take one because this one only has one. So we're going to take an A out. We can also take B because they both have at least one B. So we're going to take B out, and then we're going to write what we would have left. So if I divide the first piece by 15AB, 15AB, the 15s would cancel, the B's would cancel, and I would have one A left over. So I'm going to put A right here. If I divide this part by 15AB, well, the A and B, those would both cancel. And 30 divided by 15 is 2. So we're going to write minus 2. Okay, so this next one has 3 terms. So this one's just going to take a little bit longer. So let's start with the coefficients. So let's start with these numbers right here. What goes into all 3 of those? So 15, 5 or negative 5, and 30. So let's see, 5. Well, that looks like the smallest number, right? Which means let's check to see if that goes into 30. Does 5 go into 30? Yes. Does 5 go into 15? Yes. So 5 would be our greatest common factor. Now we need to look at these letters. So let's start with the X's. Do they all have X's? Yes, they do. And remember, you can only take out the smallest amount that you see. This one only has 1. So I can only take out 1. So we're going to put one of those on the outside. And then let's look at the Y's. So the Y's, let's see, there's 2 there, there's 1 here, there's 1 here. So I can only take out 1 because both of these terms only have 1 to give. So we're going to put 1 Y there. And then we'll put our parentheses. And I'm going to clean this up a little bit so we can see what would be left. All right, so let's start with this first one. If I divide this whole thing by 5xy, so 5xy. All right, 15 divided by 5, that's 3, so I'm going to put 3. X cubed divided by x, that would be x squared. Remember, you just subtract exponents when you do that. Same thing here, we're just going to subtract the exponents. 2 minus 1 is 1, so we would just have 1y left over. So that's the first term. All right, let's do the second term. We're going to divide this whole thing by 5xy. Well, the 5's would cancel. The y's would also cancel. And if you divide these, you would have 1x left over. You also have the negative still. So the only thing we would have left is negative x. Okay, and the last term we're going to divide by 5xy. 30 divided by 5 is positive 6. And then your x and your y, those would both cancel out. So then this is actually how we would leave it. We would just leave it just like this. And again, if you wanted to, you could check your answer just by taking 5xy and distributing it to all 3 of these, and you should end up with this, what we started with. In the next example, let's go ahead and look. This has 3 terms, so we got to make sure we look at each part. So let's look at the coefficients, 6, 14, and 10. So think about that, 6, 14, and 10. What would go into all 3 of those? So if you think about that, and if it helps, you might have to actually make a list, like make a list of all the factors of 6, all the factors of 14, and all the factors of 10. And you will find that 2 is the number that goes into all 3 of those. So 2 would be our greatest common factor. And then if we look at the letters, well, they all have y's. And the most that we could take is 2 because this one only has 2 to give up. So we're going to take y squared out, y squared, and then if we write what's left on the inside, let's go ahead and divide each of these and see what we would have left here. All right, so if I divide 6y to the 4th, so if I divide by y squared, 6 divided by 2 is 3, and y to the 4th divided by y squared is y squared. We would have 2 of those y's left over. All right, in the next term, if I divide by 2y squared, 14 divided by 2 is 7. And then I would have 1 y left over, so we'll just call that 7y. And in the last term, if I divide by 2y squared, the y squared would cancel out, and 10 divided by 2 is 5. And I'm going to bring down the minus, so minus 5. All right, and the last example here. So let's think about this. What would be the greatest common factor of 18 and 40? And again, this might take some time for some of you if you're not very good at your factors. You might have to make a list. So think about all the numbers that go into 18 and all the numbers that go into 48. And the biggest number that goes into both would be 6. So 6 goes into both of those. And if we look at the letters, let's start with the A's. So they both have A, and I can only take one because that one only has 1. And then let's look at the B's. They both have B. So we can take one of the B's because they each only have 1. And let's look at the C's. They both also have C's. And I can only take 2 because this one only has 2. All right, so this time our greatest common factor, it's a lot of stuff. It's all of this right here. So we're going to go ahead and write our parentheses, and then we're going to divide and see what we would have left over. So let's go ahead and do that. If I divide this entire term by 6ab c squared. Let's see what we would have left. 18 divided by 6, that's 3. If I divide the a's, I would have 1a left. The b's would cancel, and so would the c's. So that would be it for the first term. In the next term, if I divide by 6ab c squared, negative 48 divided by 6 is negative 8. The a's would cancel, the b's would cancel, and I would have 1c left over. So we'll call that negative 8c. And that would be it. Okay, and this is our last example. So why don't we pause the video and you guys can try this one on your own. So go ahead and try it. And when you're about done, you can look up at the screen and I will put the answer up in just a second. All right, and here is the answer. So the greatest common factor here was 5a, because 5 goes into all 3 of these numbers, and they all 3 at least have 1a. So you'd have 5a on the outside, and then this is what you would have on the inside. So this is it for the video. You can go ahead and start the work now. I know that I kind of over-explained a lot of these examples. It typically does go a lot faster than this once you get the hang of it. Once you get the hang of it, you almost don't need to do this part here. You can kind of just put the GCF on the outside, and then you can just do this division in your head, and you'll be able to quickly get the answers. So that's it for the notes. You guys can go ahead and start your work.